Feasibility of Utilizing Human Power in Households in Energy-Poor Countries by Jason Lasso and Riley De La Cruz.
As the world continues to develop, the global demand for electrical energy continues to grow. Unlike households in first world nations that have access to extensive power plants and power grids, households in energy-poor countries often rely on either inefficient, costly, or limited energy sources, which causes challenges in economic growth, quality of life, and keeping up with changes in technology.
A way to combat this issue is to find energy sources that are sustainable and environmentally friendly. Human energy, such as using a pedal-driven generator, is a promising alternative for households in energy-poor countries. Human energy uses resources that are already available, which makes it seem like a promising alternative to households without access to large power grids. In this project, we will be determining how feasible it would be for households in energy-poor countries to utilize human power as a possible energy source.
We chose this topic since we feel the most experience in engineering and physics. We decided on this topic as we created a project a year prior for the 2024 science fair titled, How Can We Optimize Human Energy Production? We felt that with our prototype from last year, we could find a way for our project to be beneficial for developing countries. We believe strongly that our work can be retained and improved for future use outside of the science fair.
What are the pros of utilizing human energy? 1. Renewability. Human power is a renewable energy source that doesn't require extra fuel or power sources. 2. It's environmentally friendly. Producing human power creates no emissions or pollution, making it an environmentally sustainable option. 3. Affordability. The materials for generating human energy are cheap, especially compared to other renewable energy sources. And 4. Health. Using a generator as a means to be physically active encourages good health and a cardiovascular endurance, which is valuable in other applications of work.
What are the cons of utilizing human energy? Number 1. Efficiency. Converting human effort into usable electricity is inefficient compared to other energy sources, as there are energy losses in both mechanical and biological processes occurring, such as friction in the wheel, calories burned from breathing, and balancing. Number 2. Time and effort. Unlike other energy sources, human power requires work from an actual person, which is time consuming compared to other energy sources. Number 3. Human limits. Generating human power is limited by the human ability to use up energy, which is minimal compared to the energy produced by fuel sources or power plants.
While human energy offers unique advantages and disadvantages, finding how feasible utilizing this technology would be is impossible without a definitive number of how much energy could be generated. So to test how much energy a household in an energy-poor country could generate in a day, we created our own pedal-driven generator and measured the daily energy output. Here is the process.
These are the materials we used in our project.
Our design begins with the foundation that we have created and optimized in our last science fair project. A bicycle is mounted onto a bicycle trainer, where a 24-volt DC motor with a smaller wheel is friction fit against the rear wheel of the bicycle. When the bicycle is pedaled, the wheels rotate the motor, generating DC voltage from the terminals of the motor. This current can then be used as useful power, provided that there is a load present.
To measure the energy output of the motor, we have to find the amount of watt-hours we can generate. Watt-hours are the most ideal unit of measurement to measure energy output since it's a measurement of how much power there is and how long the power could be used for. To find the watt-hour output of our generator, we need the following measurements: voltage, current, wattage, and the number of hours.
To measure our voltage, we measured the voltage with a multimeter set to the voltage setting. We connected this multimeter in series across the positive and negative terminals on the motor. To measure current, we did the same with an analog ammeter but connected it in series. The only other component of our circuit would be a load, as it draws current from the positive terminal. We chose a 10 ohm 15 watt power resistor as it simulates a realistic resistance of devices that people in energy poor countries would need to power, such as 12 volt batteries, small devices, and light sources. Now that we have our design, let's measure our average wattage output.
After biking and recording our data, we calculated the average wattage output of their motor to be approximately 12 watts. Now we have to figure out how much time a household would spend generating electricity. Looking at the countries with the least amount of electricity access per household, the majority is located in sub-Saharan Africa, where the average amount of members per household is 6 people. People in this region typically spend 7 to 8 hours working per day. So assuming that they each spend 2 hours generating electricity for their household per day, that is 12 hours generating electricity per household.
So with all of our values, households should be able to generate 144 watt-hours per day if they like to have an average 12 watt output, and every member of the household pedaled for 2 hours each. With this energy, it is possible to power small devices like phones, radios, and lights for hours at a time. However, it is simply not practical to power higher energy consuming appliances like heaters, stoves, or machinery, where the rated watt consumption is higher than how much is produced in a day.
So how can we use human power then? Since human power is most effective for powering low energy devices, one of the most valuable applications is charging smart devices like smartphones, tablets, and laptops. As technology advances, smart devices have become essential for communication, education, and work. Using human power as an additional renewable energy source for these devices allow other, more powerful energy resources to be redirected toward more critical needs, such as heating, cooking, or operating machinery. With 144 watt-hours, it is possible to charge a phone or tablet 28 times, or charge a laptop for 2.9 hours.
Given that human power is most effective for charging low-energy devices like smartphones, we prototyped the design to make this possible. The purpose of this prototype is to demonstrate how human energy could be used, and to showcase how a household in a low-energy country may use this technology. Our prototype is built into a cardboard box, and inside are the components to turn the DC voltage we generate from our motor into a power source that devices can be plugged into.
Since the voltage of the generator fluctuates between 0 to 24 volts, we had to use a solar charge controller to regulate our voltage output to 12 volts so that our voltage is suitable to power devices. This voltage is then used to charge a 12-volt SLA battery, which is the most common and cheapest type of high-capacity rechargeable battery. We then direct the battery's power into an inverter, so that the 12-volt direct current is inverted into 110-volt alternating current, which is the voltage rating of appliances and devices.
On the other side of the inverter, there is 3 output ports, 2 of which are USB and 1 is a 110-volt socket. This means that with our design, 3 devices can be charged at once. On the left is a photo of a smartphone being charged with our prototype, all the power coming from a human power generator.
What are the advantages of our design? Bikes, 12-volt rechargeable batteries, and inverters are often used in off-grid areas that need portable power. This means many households already have access to the important components of our design. The rechargeable battery allows for the power to be used anytime, anywhere, instead of only having access to power when pedaling. Our prototype, including the generator, costs less than $150, which is substantially cheap than other renewable energy sources.
Based on the data we've gathered and tested, it's evident while human power cannot compete with renewable energy sources like solar, wind, and efficiency, it can still serve as a valuable supplement. In energy-poor countries, human power could help households reserve their primary renewable energy sources for essential needs like cooking, heating, and water access, while still enabling them to power other devices and expand their energy usage. With our prototype design, we demonstrated how human power could be harnessed to store electricity and charge low-energy devices such as phones, laptops, and tablets. As society becomes increasingly dependent on this technology for communication, education, and work, solutions like these could help bridge up a gap for communities with limited access to reliable power.
Thanks for watching!